How you guys doing today? You got a little rain today, so can't run all the cars like you want to?
No, that's right.
So
should stop
John
here in a few hours.
Warniak was with SEMA for years, and try not to bring that up, and joined Connect2Car early on, right after I left CTA, probably back in
2000.
2000, yeah. So not long after we kicked it off. So it was, John's been with me longer than pretty much anybody, and has always been my partner in crime, and he's brought me to the show that he used to work for, and I had a few fun panels there. My favorite one was when I had the audience close their eyes. You know, the one where
The backup
where they sat down. Yeah, Graham won't make you do that. But this is a really cool panel. Now, going to the gemba, John will explain, so I'm not going to spend a lot of time. He's going to introduce all the panelists, but I wanted to introduce John because John has been a great friend over the years, sometimes a mentor. When I can't figure something, sometimes a mentor.
Sometimes a pain in the ass.
Sometimes a pain in the ass. But in general, I appreciate all you've done over the years to pour into this panel and keep it going for, this is our 23rd year for Connect2Car. It's the longest running automotive panel at CES, and hopefully we'll continue to do it year after year. I appreciate everybody coming in after lunch. I know it's a little tough getting back. I'm sure there'll be some folks trickling in, and we've got 2 more sessions after this. The Digital Disruptor, which will be a fun one, and then Steve Greenfield will be back with Changing the Channel, talking about the whole dealer channel. So John, without further ado, all yours, boss.
Hey, buddy.
Thank you, sir.
Thanks, Chris. Good. How many folks were here this morning for some of the sessions? Wow, good repeat, good repeat. A lot of great content. And as we said earlier in Chris's remarks this morning, this is not an average session. This is meant to push the edge, just like the Indy Autonomous Challenge is doing. Corner cases, edge cases, and talk about the core, what's happening in automotive certainly, but to really push beyond the average. You get out to the ends of the distribution, if you will, and that's really what's pushed this session for 23 years. And Chris actually coined the term Connect2Car back then, so pretty provocative thinking way back then, and connected car has taken on a lot of different definitions through the years. We'll talk a bit about that. Going to the gemba, faster, smarter, cooler, and safer. For those of you that may not be familiar with the term gemba, it's a Japanese term, which means the front line, going to the place where value is created and where the action is. So getting out to that. And racing has long been the gemba for product development innovation, and particularly the Indy 500. And what's happening down at Indianapolis, particularly that Paul and Rob that we'll be talking about today, has really pushed the limits, and we'll be talking about the autonomous racing, et cetera. But racing is part of our connected, autonomous, and electric future. No doubt about it. What we learn from racing and really making vehicles faster, smarter, cooler, and safer. We're going to talk about some of that today. Companies race for 3 reasons. Solve complex problems to advance the technology, demonstrate that technology and proof of concept on the world stage, so you're putting it out there, and then inspiring the next generation of STEM and STEAM leaders, the talent development pipeline. So you race for those 3 reasons, and this comes from right from the OEMs, General Motors, Jim Campbell, Dave Wilson at Toyota, et cetera, Ford, Jim Farley, that have been through the panels through the years. But the 4th reason, the biggest reason, the goal, if you will, of those 3 objectives, is to win. And that's what Chip Ganassi and Roger Penske and all the rest, Rick Hendrick, put together. You're out there to win. And the 2 fastest ways to accelerate innovation are either racing or war. And today we have both going on with lots of different things. Rob was part of a panel we had at GVSETS, which is Global Vehicle Systems Engineering Technology Seminars. That's a mouthful. But pushing that with what's happening in Ukraine, the technology, we've got racing technology transferring today to the military. And you'll actually see one of those vehicles in Rob's presentation. Defining eras and attitudes. Racing and performance have defined eras and attitudes. We've got a Tiger team here from Fox Factory. Literally, first time at CES, but developing some of that talent and that technology to push the performance technology into some of the new things. And certainly with Clemson. CUI Car, I've been very fortunate to be on the board for the last 14 years, is one of the leading universities for putting together what we call the triple helix model, which is basically how do you integrate government, industry, and academia. And that's kind of like the catalyst, if you will, for some of you may be familiar with the DARPA challenge 15 years ago. Well, the son of DARPA is here, manifested in Paul Mitchell's basically Indy Autonomous Challenge. and we'll hear a lot about that. Vehicle complexity is outpacing our ability to management. This is the first time, if you heard Steve Greenfield earlier this morning, we'll see more change in the next 10 years than we have in the past 100. And as Mary Barra put it very, very well, think of the vehicle as a software platform. How many companies here are software companies? The rest of you are, but you don't know it yet. And will become, because that is part of it. You won't be selling parts. You'll be selling the fusion of sensors and intelligence and lots of different things. We'll talk. Software safety, digital vehicle architectures are the new performance metrics particularly. It's no longer the horsepower wars, it's the kilowatt wars, WTF, and that's not what, it's watts to freedom. And that's where we're heading. The generative design, additive manufacturing, digital twins, they make the impossible possible. And you can test and reconfigure, as Paul talked about with some of the cars that are, the 9 teams that are out at the track today. By the way, how many folks are going out on Saturday to the Indy Autonomous Challenge? That's the second time they've raced here. Unbelievable. Come on. Lie. Just lie. If you
I'll be there.
So there we go. You got a lot of people showing up. Well, great. And mobility platforms, personalization, partnerships for accelerating V2X and V to everything. And Courtney's going to tell us a lot about that, what's happening at Panasonic. Indy Autonomous Challenge. There are rare moments in history when the incredible, if you will, passes into us, our present, and into our past. 23rd of October, 2021 was one of those moments. $1 million prize to that team there. Technology University Munich, is that correct, Paul?
Technical University.
Technical University Munich won that prize. It was so cool to be there, to see that being made. And we think not many of us could have been there back in 1908. When I think it was what, Charles Fisher started the Indy 500? But you could have been there at this. So to be at the track on Saturday is one of those moments. And it's really pushing that. And that race at first was here last year at CES, and this Saturday will be the second race at CES. Very cool to be part of history like that. On the other end, if you will, take that autonomous vehicle racing out of a structured environment, like an oval, and Paul will tell us more about maybe it's going to go to road courses, etc. The King of the Hammers, and if you're not familiar with the King of the Hammers, it's the new Baja. It's basically rock crawling in a high-speed desert, so you have to go from basically doing 2-3 miles an hour over a boulder the size of the car, or around it, or through it, whatever you can, out to doing 120 out on the open desert. And for companies to be able to do that, and then pushing that envelope with EVs. It's kind of a mash between kind of Burning Man and some of us, Woodstock, mashed together with Baja. And it's all there together. And you've got some great companies help form the technologies to be able to do that at speed. The rock portion of Hammers is only about 15% of the course length. And it takes about 7 hours to win that race. The rock portion, 15% of the duration of the race, takes up about 65% of the time. Truly a challenge. So I mention that because it's an unstructured environment for autonomy and certainly EVs and a lot of things we'll be talking about. And some of the packages, we actually introduced that just this past February. So that's the kind of the EV gemba where it's at in racing. What about the AV gemba? I mentioned the DARPA challenge. If you take a look at the Razor Polaris there, the things that are happening with the DARPA program, and that RACER program is the robotic autonomy in complex environments and resiliency, typical military, right? Nat Buse would know that, right? That's a big program. But you've got companies, as I mentioned, like Fox with their live valve technology on that Ford Bronco Raptor that you see there, that are semi-autonomous or certainly active suspension that can actually anticipate what the vehicle is going to go through. You start taking all those sensors and all that data that we talked about earlier this morning and fusing that together at speed in an off-road environment. So a lot of the learnings that are going to go into the Hammers and these autonomous systems for military and racing will come out of the Indy Autonomous Challenge. So if you haven't been downstairs, make sure you get down to the Indy Autonomous Challenge Innovation Paddock down there. There's 10 companies supporting that, and certainly just about everything you see down of the 200 exhibitors downstairs are a big part of that. Then you got companies like Chip Ganassi Racing. You got the Dallara Honda that won the Indy 500 with Marcus Ericsson and the Ganassi team. But they also field the Extreme E with, in this case, an EV Hummer with General Motors. And I'm glad to say the first woman that has ever won a race, championship race like that, with Ganassi teams is Sarah Price. First woman in history to do that. Pretty cool. She did that in Africa. I mean, that is a cool thing to do. And with that, I mentioned, you see some of the companies there, iCar particularly, that Rob will talk about, and some of the tools and processes that go directly into racing and will make its way into our vehicles. So that's kind of the way I want to kind of frame this. This is going to be our folks that we have on the panel. What I'd like to do, before I ask Rob to come up, is let each of you know that we're going to give each of these speakers 5 minutes to kind of introduce some of their key remarks, some of their key messages, and we'll go through that fairly quickly, 15 minutes or so between all three of them, and then come back, and we want integration. What we found, Chris and I, through the years is that you came here, you want to hear the insights and perspectives from these people. They're part of the gemba. So we're going to jump to that. So what I'm going to do is we'll go right to you first. Rob, tell us a little bit. You want your slides to come up? And,
Sure, yeah.
Okay.
Want me to come up there? Or?
Yep, wherever you like.
Okay.
Wherever you're comfortable, buddy.
Well, thanks, John. My name is Rob Pruka. I'm a professor at Clemson University in the Department of Automotive Engineering. And maybe I can skip through to the next slide here. Or maybe just hit that button.
Beautiful.
I guess I'm here today to talk about one of those pieces of the triple helix that John mentioned, which is the academic piece of it. And one thing we discovered in the Department of Automotive Engineering at Clemson almost 15 years ago now is that you can't teach how to design complicated systems out of a textbook. You pretty much just need to go ahead and try to build a car with the students. That's what we found out. We call that process Deep Orange. I happen to work with an outstanding team. I see some of them in the back. Troop Diancho, Chris are back there. An outstanding team of faculty and staff. And we basically design and build prototype cars with our students. And so we start out with a customer and or some kind of grand challenge, and they go all the way through during their master's program and ultimately build a car and release it and unveil them, say, here at CES. You'll see the 11th generation down there. And we try to, what we're really trying to do are prepare the world-class students for this super complicated industry that they're going into. And of course, we try to hit all of the mega trends that are going on in the automotive industry, which is the electrification, autonomy, shared connectivity, all of that, and all of the other more traditional aspects of the vehicles too. So we have gone. We're actually on our 15th generation that's ongoing now, and if you can look down there there's one Deep Orange 11 for ExxonMobil. That one was that's actually downstairs in the Indy Autonomous Challenge booth, and I'll talk about Deep Orange 12 here in a second. But you can see what we try to do is really immerse our students in this environment where they're working at an automotive OEM. We act like a small OEM, and we try to partner up with other car companies and other suppliers and actually just get our students that education, that real life experience of building vehicles. And so you can see some of the OEMs we've worked with over the years. And I think probably the main one to celebrate this week, obviously we have Deep Orange 11 downstairs you should come and check out, is really Deep Orange 12, which is in about 2009, I guess, at Indianapolis Motor Speedway, I was invited to an event that Paul put on.
2019.
2019,
Yeah.
sorry, yeah, I feel like, is that my fault? Thank
10
you.
years.
So 2019,
Good correction.
at Indianapolis Motor Speedway, where they had professors from all over the world, and they had this idea of let's go out and race, head-to-head racing with autonomous race cars at Indianapolis Motor Speedway at the time. And it's a super hard challenge. And I looked around the room, and I was the only non-computer scientist, it seemed like, in the room, or one of the only ones. And I was really interested, in designing the car. And we thought, well, hey, this is a great thing to do. Paul and his team, which you'll hear about in a second, they already had put together a really strong group of companies, like, for example, Dallara, there to help put this thing together. And so we said, yeah, we're on board. We're going to make this our Deep Orange 12 project and to let our students go through and design and build this vehicle. We actually don't race the vehicle ourselves. I don't know if that's fortunate or unfortunately, but it's a conflict of interest to design the car and get out and race it. But we were on board right away because they had the idea of doing a STEM competition, essentially. It had hundreds of students around the world that were going to participate in this. And, as a university, education is our business, and so we really wanted to be involved. So you can see Deep Orange 12 there. And in the process of what we do is we worked with these companies from all over the world. I think we had 36 partners. Energy Systems Network was really the lead with EY for us at Clemson. This outstanding group of people in Indiana that ultimately wanted to bring this to reality. And we worked with them and others to try to come up with all the different partners that would be involved. And this is, I suppose, out of date slide, but from when we did this ourselves at Clemson, these were all the companies that we worked with, and then as you'll hear from Paul, it's taken off from here. And to give you a little bit of example of what it looks like, here's last year at
Accelerating to
CES.
160 now, 165 down the front straightaway. 2 maintains that 150 mile per hour speed. Polymove accelerating to the outside, 168 through the corners, nearly to 169. Now they crack 169, accelerating onto the front stretch, and a spin from Tomb down to the infield. Elation in the Polymove pits. They are the champions of the Autonomous Challenge at CES.
So it gives you a little bit of a feel for what these cars have achieved. There's no driver in there. Obviously, they're making all their own decisions by themselves, and I think you'll probably hear a little bit more about this from Paul.
Sorry to interrupt, but what Rob's not saying is he is also, when he's not doing these panels, he's the commentator on our Indy Autonomous Challenge. That's
Yeah,
right. He's
that
one of our.
was my debut.
He's one of the two
Yeah.
people that does all of our broadcasts. He's got another career that he doesn't always tell people about in broadcasting.
Yeah,
Does it pay more than the professorship?
not yet, but maybe someday, yes. So anyway, I hope to hopefully see you out there on Saturday. I guess that's all I have for today. I'm looking forward to some hard questions from John. So, thank you.
Cool. Thank you, Rob. And Paul,
Sure.
tell us more about the IAC and ESN as well.
Yeah. So first of all, thank you. It's a pleasure to be with you, and
Glad
it's
to
always
have
good
you.
to be on the same stage with Rob, and wonderful to meet some new folks here. So I'm Paul Mitchell. I wear a couple of different hats. So for the last 15 years, I've been president and CEO of an organization called Energy Systems Network. And really our focus is, I hadn't heard it called that, it's quite interesting, the triple helix model. So our focus has been on putting together projects that involve industry, academia, and government. We're based in Indiana, so a lot of the work we do is supported by the state of Indiana, but we work with other countries and other parts of the U.S. as well. And historically, we've done a lot of work in things like electric vehicle technology development. We helped launch what was at one point the largest all-electric car sharing service in North America called Blue Indy. It was successful until the Uber and Lyft model emerged, and suddenly people didn't want to drive their own car sharing cars. I know the car sharing industry has struggled with ride sharing, but it was super innovative at the time, nothing like it in the U.S. We've also worked in deployment of some of the very first electric buses, the first all-electric bus rapid transit system. But none of our projects really were ever something that had a big global profile. They were always kind of working in the background, taking technology to the edge and demonstrating it in some type of real-world environment. Then in 2018, the organization I led was talking with leadership from the Indianapolis Motor Speedway, a guy named Mark Miles, as well as leadership at the state of Indiana, and saying, what can Indiana do to really make our mark in this emerging industry of autonomous and connected vehicles? At that time, there was a lot of states that were going down the path of creating test beds. So there was a big focus that the federal government even had that said, okay, we're going to designate these autonomous test bed locations, and all the companies will go to those test beds, and that's where they'll develop their technology. Turned out the industry kind of leapfrogged that and began to do most of their testing on urban and suburban roads, and found communities that embraced that. So we knew at that time we didn't want to build a test bed. What we said was, we've got something that others don't have, which is kind of the original test bed for automotive technology, the Indianapolis Motor Speedway. And we have a long history in motorsport. Many of those companies you talked about are actually based in Indianapolis. There's just a tremendous history in Indiana around motorsport. And honestly, not just IndyCar. Of course, IndyCar is kind of the pinnacle of that, but we've got organizations that are running all kinds of championship series around the world. So we said, what can we do to combine the prowess we have in racing and motorsport with this desire to be a leader in connected and autonomous vehicles. From that grew this idea of trying to bring back the impact that DARPA had to launch the autonomous vehicle industry. And I don't know that we were as eloquent in thinking about this at the time, although I certainly articulate it now quite often. motorsport was important because DARPA did a lot for autonomous vehicles in the low-speed urban suburban robotaxi use case. And if you look at the companies that were formed out of DARPA, almost all of them focused, at least initially, on the urban suburban robotaxi, drive anywhere, navigate. And that comes from the fact that the winning car in DARPA, I think, was averaging 19 miles per hour, maybe 19.2 miles per hour. So there was a gap where private industry, the startups coming out of DARPA, were not tackling the challenge of high-speed automation. And when I say high-speed, I don't mean 50, 60 miles an hour. I mean above 100 miles an hour, potentially above 150 miles an hour. You asked the question, well, why does that matter? Why should we have high-speed automation? Well, first of all, we all, I think, that care about the autonomous vehicle care about human safety, and we also care about kind of improving commerce. And you think about where most highway deaths occur, they mostly occur on most deaths occur, accidents occur, they mostly occur on highways in situations where two cars are colliding in greater than 70 miles an hour. And also, if you think about the supply chain challenges that we have and just the challenges we have with commerce, that's mostly over-the-road highway trucking. So if we could have autonomous technology that could safely operate at 150 miles an hour, 130 miles an hour, I'm not saying that's going to happen tomorrow, but if we can get to that point, we can save a lot of lives and we can move commerce a heck of a lot faster. So those technical challenges is really what have driven the research community from what started out as 31 universities from around the world. We now probably have, I don't know, about 16 universities that are still involved. To drop everything and focus on this grand challenge of developing the AI drivers capable of piloting fully autonomous race cars. ESN and our partners at Clemson designed and built the initial car. Now, since then, Indy Autonomous Challenge has updated and made changes to that car to make improvements, to make it more robust, to make it better and faster. Here we are. It's back at CES for what we think will be another history-making event on Saturday. It is open to all CES attendees. There's no need to register. You have the opportunity to register, but if you make it out to the track, as long as you got your CES badge, there'll be all kinds of fun stuff for you to see. We'll have a DJ, we have big video boards, there'll be concessions out there, and hopefully you'll see records being set with the world's fastest autonomous race cars. The last thing I'll just say is, our goals with all of this are to advance the technology for industry, attract the best and brightest minds to work on this challenge. And if you care about the automotive industry, you have to realize that people working in AI and computer science and machine learning, they can go work for any industry they want, right? There's all kinds of industry at CES here that wants to hire the brightest minds in AI algorithms. So we are working to get them to focus on automotive, and we think we're doing that as a service for the automotive industry. And then third is to kind of shock people and win over hearts and minds. If people can see an autonomous vehicle going 170 miles an hour, they look at that and they say, "Oh, I can't do that. That's pretty amazing." You're seeing AI do something that only the most elite human race car drivers can do. It's maybe a different experience than somebody seeing a robo-taxi go 20, 30 miles an hour, which most of us should be capable of doing on our own. So I probably took up more time than I'm supposed to, but.
Nope, that's fine. Thank you, Paul. We mentioned early on, too, we're going to talk about what's now, what's new, and what's next. And we're very fortunate to have Courtney Ehrlichman here from Panasonic and Next Lab. And so, Courtney, tell us about
Thanks for having me, John. It's such a hard lineup to follow here in terms of intro, but I will be hopefully quicker. It may not make sense why Panasonic is sitting here on this panel, but I want to tell you a little bit about my background and where I come from and what I'm now doing at Panasonic with the Next Lab. So my background is actually I come out of Carnegie Mellon University, the Robotics Institute there, DARPA Challenge 2007. We won with the boss. Definitely not as slick looking as your vehicles, so, but that was a long time ago. And all of those companies I came out of there, it is very interesting what you were talking about. Robotaxis, we know that Chris Urmson, who was on that team, is now running Aurora, focused on freight. So the whole autonomous industry is kind of shifting. I'm sure you're all aware of the announcements that have come out in recent months and the consolidation that is happening. But so I was working there, and I ran 2 national US DOT research centers. So basically, I want to kind of bring the gemba into this. My role there was actually going out and finding what the challenges were and coming back into the university, into the Robotics Institute, and asking these really smart people, how can we solve challenges using these technologies? We were also a designated connected vehicle testbed from the government. Can't say a lot of companies were using it, but it was very interesting in terms of pushing the conversation forward, which I think is exactly what racing is doing. Fast forward, I am now at Panasonic at the Next Lab, which is, Panasonic is a very large company. Some of you might have used a Panasonic toothbrush this morning. But at the Next Lab, we're part of the Smart Mobility Office, which is a branch out of Panasonic Automotive, and we're really focused on the next thing. So Panasonic Automotive does many, many things. Just announced integration of Alexa and Siri with CarPlay yesterday, so you can control things in your house from your car, which is pretty rad. But we're really focused on connecting everything together. So not just the sensors and the fusion that's necessary within the vehicle, but also connecting to OEMs, to users, and to the cloud. Also infrastructure. So as we're talking here, we're talking about the connected vehicle testbed, that's connecting to intersections, but also now with the new infrastructure bill, we need to talk about connecting to chargers and the grid. Panasonic is really focused at bringing all of these new technologies together and putting them out in the market at scale. And that is a really hard problem. And I'm really excited to continue the conversation here about how we go from the base of innovation, R&D, to bring technology to scale. Thanks.
Excellent. Thank you, Courtney. This is, I think, the best part. Now we can kind of get your insights and perspectives. And one of the things I want to start off with, a lot of the technologies that we see out on the floor, and particularly I'll call the stuff that's out on the edge, the newer stuff. What are some of the technology readiness levels of some of the things that we're seeing? We're going to start with you, Rob. In terms of some of the technologies, and kind of segue to Paul as well as you, Courtney, with what we're seeing on the floor, what are they ready for prime time, as Courtney just mentioned, to scale? What do you see, and what could be further out?
It's a difficult question, John. I mean, there's so many areas. I think it really depends probably on the application, where they're actually trying to utilize some of these technologies. And, in my head, if we're going to, when I think about autonomous cars, or when I first heard about them, I thought it was just, something that all of us were going to buy from a dealership. I think we're a long ways from that, right? Because it's really more maybe about the customer limiting it there, because maybe not all the customers really want that, but if you put them in the right application, they're probably ready today, in pretty much all of these areas. If it's a very controlled environment, they're ready today. So it really kind of depends. And I think the piece of it that maybe as a technical person we don't always understand is really it's the customer piece, and how you actually get this thing into the marketplace and find people that really want it, right? And so to me, that's part of their part. The technical side of it, I think we can handle pretty well, but ultimately the business case of it is the part that I am still trying to learn about a little bit more, and I think that's really where a lot of the things may struggle.
Yeah, I think the whole industry is. I think, we've been talking about level 2, 3, 4, and 5 autonomy for the last 5 years here at CES. Yet we're seeing it happen at the track. I mean, Paul, the technology readiness level of your suppliers and partners, they're doing it.
Yeah, so my take on this is that the individual pieces of the puzzle, the individual components and the base software are all pretty ready. So there's great LiDAR technology from perception. There's great LiDAR, radar, optical. There's great GPS, GNSS. There's good drive-by-wire systems. There's all kinds of supercomputers that can handle as much processing as you need. There's good simulation packages that can train AI algorithms to operate in different autonomous environments. There's good 5G and LTE connectivity. There's other private wireless type connectivity like what we use with Cisco. So the bits and pieces, the components, and that's a lot of what you see on the show floor, are all pretty damn good. And they're obviously capable of making cars go 190 miles an hour autonomously, and they can make a mining machine go autonomously. I saw one down there from CAT. I think the challenge is systems integration. I think we are finding in our vehicles that the packaging of these components in a way that is durable, that is reliable, that is eventually cost effective is really hard. And getting all of those systems to communicate with each other at all times, whenever you need it, under any circumstances, and eventually slap a 10-year warranty or a 5-year warranty on top of that is where I think the challenge is. If you go open up the cockpit of our car, I think frankly, Clemson did a great job. We've done some iterative improvements. I think we've got a pretty elegant way of incorporating a full autonomous stack into a small space, and that in and of itself has been a major technical achievement. Now you go look at a lot of autonomous prototype vehicles that are driving around, you open up the back trunk, there's still a lot of wires, there's still a lot of server rack type stuff going on in there, and they're going to have to get from that down to something much, much more reliable, smaller, less complex, and it's going to take companies like Panasonic and others that are used to moving from, okay, we can get this to work, to we can get this to work whenever, wherever, at a reasonable cost and at scale. And I think that's where we're at. And I think we're still a little ways away from being at a point where these autonomous prototype cars that you see out here can just start driving around and be reliable for 10 years.
Yeah, and that's level 5 autonomy, right? I mean, that's,
Yeah.
and it's unfolded differently than a lot of people would have predicted, I think. Courtney, from your perspective, I think, and you were part of some Tiger teams as well, so you've brought a lot of this to scale, as you say, at Panasonic, and with your background at Carnegie Mellon, et cetera. What do you see as the readiness level for some of the things you see here at CES this year?
Well, I want to build on what John was saying. I feel like you just teed it up for me so nicely. I think the technology is there. We've all said that. The technology, I mean, coming from CMU, we've always had that technology sort of understanding that the readiness will be there much sooner than the market will be ready for it. So there's two things. There's the very vast different bits and parts you were talking about that need to be integrated. It's how that integration then connects to the things I was talking about before, having those platforms where all of that data can talk to each other and make sense and provide insights and make decisions. That's really important beyond just the vehicle, so moving throughout the world. And then there's interoperability. So you have all of these different companies that are building these different stacks, and if they can't talk to each other, you're going to have one vehicle that can work, or how are they ever going to actually be maintained, right? Like when I think about autonomy, I think a lot about maintenance and training the next mechanic. And then the other piece, so there's interoperability, and then there's business models, right? So what is the correct business model to roll out this technology? We had the, what was the scooter that was created a long time ago, the Segway?
Segway.
Was supposed to be amazing, but the business model wasn't there, and the adoption was not there, right? So we also need the public to be very comfortable with this, and we're seeing that as a major hurdle. We're continuing to see that as a major hurdle. So to add on to that, I'll add one more thing. I think we also need to have vocabulary that consumers can understand between level 1 through 5 and understand what their vehicle can do and how they can interact with it safely and appropriately.
Excellent. Let's stick with you, Courtney, I think, in terms of the connecting people, vehicles, and their data together. You've got a platform, I think, called SkipGen, I think it is, SkipGen 3, for actually doing something. And it actually came in from the, 10 years ago, IVI, infotainment in the vehicle was a big thing. But it's coming in through the head unit, right?
Yeah, so that's coming in through the in-vehicle integration. We have a lot of, we've integrated and embedded on the TCU as well. So SkipGen has moved on, and specifically at NextLab, we've developed OneConnect, which is an entire platform that we're building on and leveraging in many different ways. It's multi-tenant, so we can do over-the-air updates. We can connect with OEMs and send data back to them. We can send data to the actual operators of the vehicle. This is really useful also with electrification, so knowing the state of your battery and the charge. This is really important too, moving forward to actually integrating all of the in-vehicle entertainment. As we're moving towards autonomy, you're going to have less attention being paid to the road and more interest in actually what's going on inside the car. So again, all of these platforms need to connect together. One thing that Next Lab is really interested in is, partnering with different companies and different users to make sure that this is not, it's suitable across all vehicle types. So working with fleets and their connection to chargers and the grid, working with motorcycle companies to make sure that they can connect with their drivers, working with governments to make sure that they connect with their infrastructure in the vehicle as well.
Excellent. As vehicles get more complex, that we mentioned, and by design, and they get more kind of locked down, if you will, and cybered up, there aren't that many qualified companies that can actually tap into the vehicle, particularly if you want to personalize it, upgrade it. And as we heard earlier this morning, that's going to be done through subscription services. The vehicle will come with a lot of these features on them, but they won't be activated until you punch in that you want to purchase them. And so that disruptive by design, if you will, those technologies. Rob, some of the people, how many graduates from CUI Car already in the industry?
So about 1,000 overall.
1,000?
Yeah, about 1,000 master's and PhD students.
And I
out
think
there.
Deep Orange 10 hired what? Everyone at Ford? I think they hired the entire team.
Yeah, just about.
It's
Yeah,
pretty-
yeah, they're in demand for sure. If they make it through the program, they're in demand because they have this background of systems integration. We heard about it, right? And trying to make these different pieces that don't communicate well together, try to help make them communicate. We just went through an exercise for almost a semester, trying to improve one of the current cars they're working on, just the CAN bus communications, and trying to get everything to be very robust. These are all really common problems that were brought up, and they're not easy to solve, especially when you get components from different manufacturers.
Yeah, I mean, we're building better vehicles, obviously, but you got to build better engineers.
Yeah.
And these folks that I mentioned, they're not afraid. They're digital natives. The technology does not intimidate them. The pipeline is robust, and certainly Deep Orange is a big part of that with 1,000 grads, and they've all got great jobs, I think, and performance.
Our challenge is to try to produce students that will be relevant in 30 years. And none of us, think about what the auto industry looked like 30 years ago, there's kind of no way to know what it's going to look like 30 years from now. We can guess at it. And so it's really about a way of thinking, right? And so, like you said, don't be afraid of a new technology. Just kind of go after it, right? And teach them how to think, really, and how to approach a problem and break it down in a certain structure. It actually really helps. And those are the kind of things that we're really trying to work on and put into our students before they leave our program.
Absolutely. And Paul, you're right at the gemba, if you will, with the 9 teams that are competing on Saturday. I mean, that is the future the next 30 years. Those are the folks that are going to be presenting here long after I'm gone.
Yeah, so I mean, I think, as I kind of mentioned earlier, our goal with Indy Autonomous Challenge is to create a program that is compelling and exciting enough that people who are studying AI, machine learning, sensor fusion, advanced robotics will say that's cool enough for me to focus on during my PhD program or my master's program. And the reality is we're in an era of technology fusion. So if somebody's going to Carnegie Mellon and getting a degree in advanced robotics, they're not an autonomous vehicle person any more than they are a rapid drug discovery person, right? So basically, the idea is how can you get the best and brightest minds to focus on this challenge of autonomous mobility. DARPA certainly was a moment in time that attracted a lot of that talent, and we're trying to build on that with the Indy Autonomous Challenge. And so I do think that, frankly, without us, not saying just us, but without things like Indy Autonomous Challenge, that the automotive industry is not going to be able to get that talent to focus on automotive because there's just so many applications of this technology fusion that's out there. And as fun and as sexy as some of us think automobiles are, we know that the younger generation is less and less interested in the allure of the automobile itself. So I think that we're in a real race for talent. And as a person who cares about the mobility industry and the automotive industry, I think we have to be realistic about what it's going to take to get that talent to solve problems in the mobility industry not necessarily at the expense of aerospace or drug discovery or those, but there's a limited talent pool out there.
Cool, thank you. So this is our white flag lap, our last question. We're going to start with you, Courtney. And what's the most important thing you think this audience should know about going to the gemba, making vehicles faster, smarter, cooler, and safer? So that's number one, first part of the question. What's the most important thing this audience should take away from today? Second is, if you were having that dinner meeting out at the track tonight, or some of the CES partners here, who would you want to have at that dinner meeting? And they could be dead or alive, doesn't matter.
This is great. I do like live people. So what I want folks to take away from this is that there's a lot of sexy technology there. I really admire the racing, getting people involved. But really that integration and scaling it up is the biggest challenge. And we really need to all work together and not build silos across technologies. We actually need to work horizontally and be interoperable. In terms of dinner, I just met someone before the panel from the Clemson team, and I would like to go to dinner with her. She's working on the electrification part. And can you just remind me of how we just met? Troop D. Are you here still? Can you raise your hand?
Wow. I don't know if she's in there.
Yes, we'll go to dinner. Thank you.
There you go. Wow, that had that as a response. Thank you, Courtney. Paul, most important thing, and who would go to dinner with you?
I'm just going to be shameless and make a plug. I think the most important thing that everybody should take away from this is that they should come to the Las Vegas Motor Speedway on Saturday to watch the Indy Autonomous Challenge in person. There will be busing leaving from West Hall starting at 11 o'clock, provided by CTA. They'll take you out to the track. They'll bring you back. You can also drive yourself or take an Uber. Parking's free. There's no cost, and it'll be an incredible show. In terms of who I'd like to have dinner with, I'd probably go back in history and, try to get with somebody like Carl Fisher or Jim Allison, the people that got the Indy Motor Speedway started, and frankly, just to see what they think of what we're doing and the connection between why did they build that track and did they ever think that it was going to be, what it became, just personally from being in Indy and being in Indianapolis. I think that'd be really cool.
Yeah, I think Carl Fisher would be very proud. And the Indiana Economic Development Corporation, I saw their plug today on the tube when I was getting ready this morning. And really, with Roger Penske and the narration and that, it's pretty impressive. So I think Carl would be proud. So, Rob.
Well, I guess the message would be get involved, right? Paul mentioned it earlier. It's really hard. Everybody's going after everybody comes into our facility and says, we want your best students, right? And the way to get great students is to get involved. And so I think that would be my main message. Get involved in things like the Indy Autonomous Challenge or, your universities, because they need your support, right? They need your advice and your mentorship there. And I think, Paul also mentioned cars need to be cool, right? And so I would go to dinner with Ken Block. We unfortunately lost him this week. Nobody made cars cooler than Ken Block. If you haven't watched his videos, you need to watch that. Through our Deep Orange projects, we usually watch videos of Ken Block doing jumps over train tracks in front of a train and whatever else, right? The guy was amazing. He did a lot to inspire a younger generation of car fanatics, right? So I definitely would like to go.
He certainly did.
To dinner with him.
The inventor of Gymkhana, if you will.
Yeah, absolutely.
Certainly take that. I'd like to welcome Chris Cook back up for the final comments. And first of all, I want to thank you, Courtney, Paul, Rob, for being with us today, and thank you.
Thank you, John.
Chris?
So since I get to ask a question,
Oh, you do?
so how long before we get to a point where the autonomous Indy vehicle is beating the driver? I mean, it's I don't even see that in the challenge or anything like that. But when you're thinking about it and you're seeing the technology, is this something you see in a year, 10 years, or 20?
No, yeah. It's a long ways out. I think that we're not that far out from Indy autonomous cars being able to replicate the driving styles, the race lines, make decisions the way a human race car driver can do. I think the challenge with trying to run something like the Indy 500 is the long hours, the endurance, the constant having to make those decisions and replicate them over and over. Now, 20 years is a long time, so certainly maybe in that time frame. But in the near term, the elite human race car drivers are really very special human beings. That said, our AI drivers are better than about 99% of human drivers.
Yep. And that, to jump on that, Chris, I remember posing that question to a set of drivers, and it was actually Colton Herta, one of the youngest Indy drivers, and he says something very profound. He said, if that Dallara AV21 or the next version of that autonomous Indy car can do 300 miles an hour safely around, let's say, the Brickyard, he wants to know that so that he can push it to the limits. And as Paul said, the AI takes a lot of that risk out of there. That gives the driver a lot of confidence. So it isn't about, we're always going to have a Takuma Sato, a Scott Dixon winning the Indy 500. But to solve these edge cases, what we talked about earlier, why companies race, why technology is the gemba, and the front line for a lot of these technologies.
And I think the area where, the technical area kind of where we would struggle the most in beating a human is really the tire. And the human drivers, they can sense that the tire is changing throughout a corner very, very well. They have an amazing sense for that. And that's really where all the forces are generated, and so that's where all the speed comes from. And so I don't know that the autonomous vehicles have come up with a good way to model that super complicated tire. They look simple, but they're actually really hard, and that's probably the area where why I would agree with Paul that we may never beat them in some way. You may be different and better in some other ways, but being able to adapt to that tire every corner is actually really
we always
difficult,
hope humans will outdo machines for the most part.
Maybe
at least
not.
in the
Sometimes.
task that we want to.
Well, Chris, we're in Vegas, so I think we need to put some money down. Make a bet.
Let's do it. There you go, yeah.
I put my money on at least 15 years.
Yeah. Yeah, I think with Brembo Sensify, Fox Live Valve, and then the tire technology that Rob mentioned, we're going to see smart suspensions. We're going to see autonomous chassis, and that'll become platforms for the innovation.
Rob, you're very right. It's a missing sense in the autonomous stack right now. I call it the sense of touch. So we have really good sense of perception. We have really good sense of brain computation. We don't have a sense of touch. And to get that sense of touch, you need really, really accurate data on not just like the tire temperature and this, but you need to understand grip, you need to understand when you're slipping, and these things are felt by the human being when they're driving a race car. There is work being done by partners like we have Bridgestone, Pirelli's doing work in this space, you mentioned Brembo, Fox, but you're going to have to get into those. Now, then the question becomes, how important is that for the commercial industry? Are they going to need that, or is this simply a task for motorsport and kind of the highest level of performance? But remember, there's plenty of automotive companies out there that sell you Lamborghinis, Ferraris, Bugattis, Maseratis, high-end performance vehicles that do want to be able to give you that kind of really high-speed performance experience.
Yep. Actually, there's a study by McKinsey that said in the next 10 years, almost all the new products haven't even been invented yet. So that'll be their biggest source of revenue, of things that haven't even been created till starting like today.
And if I could have dinner with somebody, it'd be an odd crew. It would be the two Wright brothers, Roscoe Turner, because he pushed the envelope back in the Cleveland Air Shows, and Charles Lindbergh.
Wow.
And one last one, and an important one for me, Bill Lear, because he was the one who got planes to fly without human beings, if you will, and created the, what is it?
Learjet.
No, the, what flies a plane by itself?
Autopilot?
Thank you. I'm just completely lost. He was the one that created the autopilot, and I got a full story on that because my grandfather worked with him on that. He was the director of engineering for American Airlines at the time, and they landed a plane without touch with him and Bill right in front of the media and everybody, and kind of got the approval, if you will, to start using it. Cool. Anyway, I appreciate all of you. Paul, Rob, Courtney, John.
Glad to be here.
Great panel, great interest. Oh, I'm running out of time, but go.
Okay, because Paul, you talked about it, and maybe I directed to you, Rob. So everything here has been really talked about the technology, going to gemba technology, business models. So commercialization, business models, and what are you doing at the university level? How do you see that?
That's probably a better question for Paul. This one, but
Yeah, and honestly, I mean, maybe even pass to you because I think our we are set up as a nonprofit organization, so we are still very much focused on industry, academia, and government working together to try to do these things. I don't actually have a sustainable business model for Indy Autonomous Challenge yet, right? It requires industry support, it requires government support, the universities have to buy in. So our focus is not as much on how are you going to take these learnings and commercialize them. So I'll turn.
Yeah, I'll just take that real quickly. I think I was speaking about the business model, and we're seeing that play out right now in the industry. Right, we're talking about robotaxis. We all know what happened with Argo. We've seen Aurora shift to freight. We're going to see consolidation. It's all about business model innovation. There's a long tail for autonomy, so we'll see that evolve over time. I would not make any predictions at this point. But again, one of the things at Next Lab is we're dealing with disruptive business models and creating them and figuring out what is the right business model. I would definitely say these guys are working on the technology and the workforce, and the industry can work on the business models. Hopefully you don't have to spend your time thinking about that, because it's a different challenge, right?
We got a line outside for the next one.
Great.
I
Thanks,
spoke
guys.
with the moderator for the next session.
Thank you.
That's you?
He said we got to end this one.
Good one. Thank you, buddy.
So, thanks, guys.
Thank you all.
Appreciate you guys.